Hi, again, welcome to video number 2, and this is about graphical representation of what we have learned so far. By now, okay, you should know about how to plot CAL and CML, and today we are going to continue with SML and SCL. However, without before we go further, all right, let's recap what is CAL. Okay, CAL represents all of the possible combinations of risk-free asset and optimal risky asset portfolio. So if you remember, the graph is the vertical is expected return and the horizontal is yes, variance. And then CML. CML is basically similar to CAL, only that the risky asset part is market portfolio. And in CML, we got the optimum portfolio because they have the tangent, uh, the point that intersect between the CAL and also the efficient function. SML. SML is similar to CML, only that the horizontal axis is systematic risk. So this axis is systematic risk. It is beta. Okay. So basically, when you are asked to draw CAPM model, so basically you are referring to SML. SCL later we will see it is between excess return of stock versus excess return of the market. Okay, so I let you read for a while. Basically, somewhat similar definition. All right, SML. The SML represent expected return and beta relationship of CAPM. Okay, the graphs individual asset risk premium as a function of asset risk, and we have as alpha right now. Let's draw SML. Okay, so you are given expected return of market 14%. Stock beta is 1.2. T-bill rate of return is 6%. Now here we can predict the expected return of a stock using CAPM model. So it is simply equivalent to RFR plus beta times with the risk premium, and this gives you 15.6%. So it means that given this data, alright, you can predict that your expected return of stock is 15.6%. Now question, what is the figure for market beta? 1.2? Wrong. Market beta is 1. Okay. Now, what does stock beta 1.2 means as compared to market? What does stock market beta here means? It means that your stock has a higher risk than the market risk. Remember just now, the market risk or beta, market beta is 1. 1.2 means that it's risky. What is the stock return if stock perform exactly like market? Okay. What is the stock return if stock performs exactly like market? So in this case, all right, here is no longer 1.2. Okay, it is 1. All right. Now let's plot the SML. It's easy. You need to know 3 things in order to uh, uh, plot the SML. The first one is ER versus beta. okay, versus beta here. No more variance, beta. Now you plot the SML where it intersects at 6, because 6 is risk-free asset. It means that when the risk is 0, you obviously still get a return of 6% out of T-bills is now. Okay, now you know that if let's say the market beta is uh, um, sorry, the expected return of market is 14. So you should plot 14 here, and you get market return of 14 if let's say market beta is 1.2, or your beta is similar to market beta. However, if it is 1.2 higher, obviously your stock will be higher. Your stock return will be higher, that is 15.6. Okay, that's it. That is all on SML. So, application of CAPM. We use SML as a benchmark for fair return on risky assets. SML also provides hurdle rate for internal projects. Basically, you can use a CAPM model, the formula, to calculate the expected return for a project. Now, did you notice that we don't have E in CAPM? Okay? The E is silent. The firm specific risk is silent. E. Why? What assumption do we use and how do you explain that? Okay, so we assume that when we have lots of stock in a portfolio, basically our portfolio is well diversified. That when we know that when it is well diversified, they gradually reduce the unsystematic risk until it is no longer, we assume it is no longer present in a portfolio, in your portfolio. So that's why there is no more E. E now is 0. That's why, again, in CAPM model, you see there is no E at the back of the maths expression. Okay, what is SEL? SEL plots is a plot of securities expected excess return over risk-free return as a function of excess return on market. Alright, now, for example here, SEL basically show the relationship between extra return from security, okay, this exists, and extra return from market. Normally it works like this. So here it shows that there is a positive relationship between extra return from stock and extra return from market. Or in another way of explaining it, the higher the excess return in market, the higher the possibility of excess return in stock. Okay? So now, CAPM is false based on validity of its assumption. Okay. Uh, it is, however, it is a useful predictor of expected return. However, in here, it is untestable as a theory. However, if you do research later, okay, let's say you will take masters or PhD, okay, you will see that you are going to have difficulties in finding the equilibrium between R1 and another one, the other side of the math expression. Okay, because expected return based on some opinions, expected based on some of researchers' opinion, expected return of a stock does not necessarily only be depending on systematic risk and the risk premium. There are other many more factors that affecting the RS. And that's why we have lots of extended models, which is beyond this chapter. Well, I'll see you in chapter 3 to briefly discuss on that. Not chapter 3, sorry, video 3 to briefly discuss on that.